The idea of somehow terraforming Mars to make it more habitable is a visionary dream. But though global terraforming of Mars is out of reach, the idea persists. But now, a material called silica aerogel might make the whole idea of terraforming Mars slightly less impossible. Notable people have proposed warming Mars and giving it an atmosphere, and the trick lies in the frozen CO2 and water in the planet's polar caps. If those caps could be vaporized somehow, then the CO2 greenhouse effect would do the rest. Elon Musk jokingly said that atomic bombs dropped on the poles would do the trick. The central question is, does Mars have enough CO2 and water to create an atmospheric density similar to Earth's? Studies show that terraforming Mars is not possible with our current technology. The results suggest that there is not enough CO2 remaining on Mars to provide significant greenhouse warming effect. Most of the CO2 gas is not accessible and could not be readily mobilized. As a result, terraforming Mars is not possible using present-day technology. But that was a year ago, and technology is constantly evolving. New study suggests that Mars could be made habitable if we change our thinking and use new technology. Rather than making the whole planet habitable, what if small regions could be transformed? The key behind their line of thinking is silica aerogel. Silica aerogel is not what you might think it is. Rather than an actual gel, it's a solid, rigid, dry material. It's created by extracting the liquid from a gel with a process called supercritical drying, the same process used to make decaffeinated coffee. The researchers behind this new study used models and experiments to show that a thin, 2 to 3 centimeters layer of aerogel could allow sunlight to penetrate, but would trap heat. The gel would also allow enough sunlight for photosynthesis, and would permanently warm the area it covered, allowing water ice and frozen CO2 to melt. Maybe best of all, it wouldn't need an energy-hungry heat source to do so. This regional approach to making Mars habitable is much more achievable. Unlike the previous ideas to make Mars habitable, this is something that can be developed and tested systematically with materials and technology we already have. Mars is the most habitable planet in our solar system besides Earth. But it remains a hostile world for many kinds of life. A system for creating small islands of habitability would allow us to transform Mars in a controlled and scalable way. The silica aerogel, island of habitability idea was inspired by something that already occurs at Mars's poles. Unlike on Earth, the CO2 on Mars is frozen, trapped at the poles. While here on Earth the poles are water and ice, the Martian poles are a combination of water, ice and CO2 ice. But even though it's frozen, that CO2 still allows sunlight to penetrate while trapping the heat. Images of Mars's poles show how this happens. In this image of ice on Mars, the CO2 has trapped the sun's warmth. This creates little pockets of warmth in the summer, which show up as black melted spots in the ice. As it turns out, silica aerogel fits the bill. It was first invented in 1931, and it's one of the most highly insulating materials ever made. That's because it's a very porous material that is almost completely made of air. It's about 99.8% air, kind of like a thermal window. Silica aerogels are 97% porous, meaning light moves through the material, but the interconnecting nano-layers of silicon dioxide trap infrared radiation and greatly slow the conduction of heat. These aerogels are used in several engineering applications today, including NASA's Mars exploration rovers. They are used to keep the sensitive electronics warm. The researchers set up experiments to mimic conditions on Mars. They experimented with two types of silica aerogel, particles and tiles. They found that both were effective at raising the temperature. Both were also effective at blocking dangerous UV radiation. Their results show that a 2 cm or more layer of aerogel reduced UVC radiation to less than 0.5%. UVC is higher energy UV radiation, and can be particularly harmful. On Earth, almost no measurable UVC radiation reaches the surface due to ozone, molecular oxygen, and water vapor in the upper atmosphere. It's easy enough to envision some kind of dome structure made of silica aerogel. It would be warm enough to be habitable, and would also block out UV. It could be kind of like a greenhouse on Earth, where water remained as liquid and plants could be grown.